Alrighty, we are back on day 4 for the next challenge. Um I decided to do it a little different. I gotta get ready for work, so I have somewhere around 45 minutes before I go to work. So I want to go ahead and just do one of the problems. I probably won't have time tonight after work, so might as well just go ahead and get it done now. I'm gonna skip the introduction so I can save some time. But yeah, let's go ahead and right into it. Um, so this problem is an algorithm problem. It's called birthday cake candles, and it says you are in charge of the cake for a child's birthday. You have decided the cake will have one candle for each year of their total age. Okay. They will only be able to blow out the tallest of the candles, count how many candles are the tallest. Okay. I feel like I read that really wrong, but I get that. So we got an array of candles. 4413. Okay. The maximum height candles are 4 units high. There are 2 of them, so return 2. Okay. Function description. Complete the function birthday cake candles in the editor below. Has the following parameters: an integer of an integer of array. An array of integers, right? Yeah, some days my English, my balance in English is real low, so let's just bear with me today. I have a long day at work too. Let's go ahead and see. So we're not printing anything for in this exercise. We're returning, so that's good to know. The past 3 exercises we've been printing, not returning, so it's good to see that we're here because that's what we expect when we are working with functions, right? Um, we're gonna return an integer. That's gonna be the number of candles that are tallest. Okay, so it says input format. The first line contains a single integer n. The size of the candles. The second line contains n space separated integers. Okay, that's how the input is gonna come into the terminal. Constraint. Or constraints. 1 is less or equal to n, less or equal to 10 to the 5, or the power of 5. So this right here is our array. So our array is going to be, it could be from one number all the way up to 10 to the power of 5. And the number on that array would be from 1 to 10 to the power of 7, which is good to know, again, for like other problems. When we have these type of constraints, we know that we're working with positive numbers, so we don't have to worry about edge cases where we don't have positive numbers. So that is good to know. And we get an example here. An array of 4 numbers, 3, 2, 1, 3, and we return the number of candles that the child is allowed to blow out, to put out, right? Two of them are 3, which I guess we're measuring this in they explain it units height. So the larger the integer, the tal is a candle, and we have to return the number of candles that are the tallest, right? So we're returning a simple integer, so we're gonna have a counter, and basically right off the bat, I can assume a couple things here. It's an unordered array, so we know the array is not always going to be sorted. Which is good to know for now, because we know we're going to have to look over all the operations. It's in a large array, even though it has a limited size in terms of we know how large can it grow based on this number right here, but that's a large number, right? So we know that we have to think about um, we always have to think about, at least for what I've learned so far, we always have to think about runtime and trying to maintain efficiency, but specifically for this type of exercise. And the reason I say that is because we, on the exercise from yesterday, not sure if you have seen it on the other side, but um, it should be somewhere in the platform. I decide later where I'm gonna post this, but it was a very limited array, a fixed array of 5 elements. So when we have a fixed array of a smaller number, or very smaller, we can be a little more flexible in terms of time complexity, in terms of the size of the array, right? This is something that it's good to keep in mind. Um, I hope I explain it somewhat clearly. Um, so moving forward, I think I understand the problem. Um, Pretty straightforward. We get an array of integers, and let's see if I can get my little whiteboard going on. Try to tackle this before I get ready for work. I really don't have much time as I thought. I thought I have 45 minutes. I probably have way less than that, but little challenge. I want to really solve at least one problem for today. Where is here we go. Um, this is from yesterday. We can get rid of this. And so yeah, we are going to say that we get an array of certain elements. For this particular example, I'm just gonna go ahead and do this. And we have to, this is gonna be our array, and we're gonna have numbers here. I hope I can make that a number. 6, 4, 3, 2, and 6. So we're gonna have to iterate over the array and find the maximum elements. Now, Python has some magic or built-in function called max, where I can easily find, just applying max to that array. Applying max to that array, I can easily find the maximum number out of that array, right? In this case would be 6. Now there's 2 of them, so I can always, there's probably, not 100% sure, but there's probably an extra argument I can add here, maybe 2, and say find the largest 2. Now I have to see if that method would apply when our numbers are equal or integers are the same, right? Maybe it doesn't do duplicates. So that's part of the things of using this method. Another way I'm trying to this is probably an end time operation, which is early to think about this, I know, but also I'm just trying to kind of like brute force in my head a solution, right? So let's go back to the problem. Let's try to wrap my head around it and say you have decided the cake will have 1 candle for each year of total age. You're in charge of the cake for a child's birthday. You have decided the cake will have 1 candle for each year of their total age. So this kid has 4 years old, right? That's the length of the array. and maybe the length of the array come into play when we are solving this, right? Let's think. They will only be able to blow out the tallest of the candles. Count how many candles are the tallest or tallest. 4 units high. Okay. Pretty straightforward, this part right here. I think I get that. I'm just trying to look for any how do you say that? For any egg hunt, not egg hunt, but any. I'm trying to find the saying. Oop! Didn't mean to highlight that. The first line contains integer. The size of candles array. Okay. Basically, I think it's iterating over the array and finding the maximum number, right? But the number could be. This case it's duplicate. There's 2 of them, right? Same thing here in this example. Which tells me what happened when we have 6, 5, 4, 3, right? The tallest of the candles. Count how many candles are the tallest. So I'm just trying to think any other way, which I'm trying to understand if we have 2 candles that are the tallest but the numbers are not equal, would that be part of solving the problem, right? Because that's the trick with the test cases also, and that's part of the problem, and I like that. This is obviously for some people on the other side, or for me in a few years, this problem it's a piece of cake. But what I'm trying to think is for the outside cases, which is part of the exercise too, right? I'm not trying to just go ahead and jump and write the code, even though I have an idea of the code in my head. I'm trying to navigate different scenarios where I can see if I'm missing something, right? So that's part of good practice. So the maximum height candles are 4 units. There are 2 of them, so return 2. So basically, if you have duplicates, return both of them. Now, what happens if it's 6, 5? 6, 5, 4, 3, right? I have 6 and 5 are the tallest. Is the kid allowed to blow out the 2 of them, or just 6, right? And that's kind of like where I'm trying to wrap my hair around that. I can kind of do that as a run the code and test it afterwards, but I always like to figure it out just basically all right, okay, let's go back here. Let's see if we are missing something or if there's anything we can add. So the max method in Python, it's going to help us to solve that, finding the max element in the array. It's not always going to be true for all elements in the array, so this is, let's do a quick Google search as part of the learning process, right? Again, I say this every time I do this. In an interview setting, certain things are not allowed, but as part of solving these problems, my goal is to learn completely how to solve these problems, right? I consider myself a beginner. I'm trying to break into the industry. There are certain things that I don't know, and I have to use the resources to learn them before I solve the problem, right? I just don't want to. You can't solve something that you don't have the necessary tools for, right? I mean, you can, of course. There's always ways to do it, but learn it, have the tools, and that's kind of like my approach. So I'm gonna not trying to explain everything I know. I do. Max Python function, right, or method. This I have to say, adding AI to the search now, it's such a key feature that we have for browsers because it's so cool. It just grabs everything and says, hey, this is what I found. Like, you don't have to go and look for all of this now, and I think that's where AI and navigators and browsers come in play, which is pretty cool. And this little summary here too. Um, this guy here explaining it, guy or girl, I don't know, explaining it very well, but I'm gonna go ahead and check here. The max function in Python returns the largest item in an iterable, such as a list, tuple, or string, or the largest of two or more arguments. It can also be used with a custom key function to specify a custom comparison logic. Max iterable or iterables. Key, none, default none, iterable, and iterable logic. Okay, iterable 0 or more additional iterables to compare. A function that takes a single argument and returns a value used for comparison. Single argument returns a value. This is interesting. It reminds me to some functions in Swift, and I think JavaScript obviously has that too. Default value to return if the iterable is empty. So we have this list, largest, max, for return that. Okay. Find the largest string in a list, order alphabetically. Python use a custom key function to compare. Okay, this is what I want to see. Use a custom key function to compare strings based on length. So we have strings, max, strings, key, length, whirl. Multiple arguments. Got it. You could just pass the arguments directly. No, it's so the key function is applied to each item iterable before comparison. So here we could say, for instance, just trying to think. Here we could say we can pass a function and say, is this item already in the array? Like if it's a duplicate in the array, and if the answer is yes, then we can add it to the total we're keeping. We're keeping a counter total, and that could be a way to use it. Consider using sorted instead of max if you need to retrieve multiple largest items, or the sort the iterable in decreasing in the descending order. The problem with sorted in Python is that it's an n log n time operation, and that's fine for some problems, but I don't think for this problem we need to go all the way there, right? Um, and again, I'm not trying to solve this through the thinking about the time complexity. I'm not trying to start from there, but also it's like the problem previously to this taught me that, and that's just something it sticks with me. Maybe I have to shake it off, but maybe not. We'll see. By understanding the max function's behavior and syntax, you can effectively. Okay, thank you. Let's just go ahead and see. Let's just go ahead and see a few test cases. Using the max keyword to see what other, because obviously here I can't ask questions in a sense of like I don't know some limitants we have, right? We have to find and interpret that. But the test cases is where we actually realize that what are the things we have to face? What are other scenarios that are implicitly hidden in this problem, right? So I'm just going to go ahead and do this. Return, and I know this is not the solution, right? Return max of candles. As simple as that. This has, okay, cool. Max argument 1 supports less, argument supports key, none. Let's just see what any other, okay. Yes, perfect. Well, not perfect. Actually, I forgot I have to. I forgot I have to add the counter. So what I'm returning is, so I'm gonna say talist sum equal to 0, and then I can say talist sum is equal to max candles. I'm doing the same thing here. Just bear with me. I gotta add 3. Yeah, I already know I'm approaching the problem from the wrong side, because I have to count those numbers and then add it to that counter, and then in that counter say, hey, this is what I have. Now, that's where the length. So the length of the array. If I get the length of the array, and say it's an array of length x, am I going to be able to count that? Another thing I can do is actually I can create the talist sum as an array. Hear me out. As an empty array. Append the numbers and then return the length of that array. And in that array, there should be only the talist elements, right? So in our case, we're gonna probably get a wrong answer here, right? But talist sum, I'm gonna say um, it's an empty array, but let's go ahead and append the max of the candles, right? Let's just go ahead and do that and return tally sum. It's gonna return 1, and for this test case, the result is 2. But it'll prove that I know what I did. I said it and I didn't do it. Return the length of tally sum, because I don't want the integer, I want the length. Perfect. So I'm getting 1, which is 3, we already saw, but 3 is twice in this array. So counting these numbers in the array would be magic. Now, what about the count function in Python? When you need to determine the frequency, so I'm not trying to solve the problem only by using methods, right? At some point, the whole point of this is to solve the problem in a way that I can show I can do it without methods, right? At some point. But what I'm trying to figure out is the way I can approach this, and functions like this will give me a little extra information on how to count these numbers, right? Like now I'm done. They're throwing the frequency word around, and I'm like, okay, I can count frequencies. But for that, instead of an array, I'm gonna use probably a hash map, right? So the problem grows in complication, and that's good, right? As long as I'm able to solve it without in 10 minutes. The syntax for the count is count the elements. So if I can count the max, element in the array and then add that to the list, if I can say append count the max of those integers, dot count. Okay, I apply that to the list. I applied that to the list. So it would be the candles. I'm gonna say tally sum. So candles dot count, and I want you to count the max of max of the candles. Does that even make sense? Like count the maximum numbers in this array. Now this is gonna look ridiculous here. Talist sum dot append. This is gonna look crazy, right? But that's some JavaScript bullcrap right there. Yeah, of course. Talist sum I'm appending. So I need to put this. So okay, as part of the process, right? Something I like to do is terminal. Something I like to do is open a Jupyter notebook and just go through some code and try some test cases on my end and see how the code is behaving. The whole idea with this video is to be as transparent as possible. Like, I'm not trying to like solve the problem here first and then come here and show you how I solve it. I'm actually showing how I can, like, what is my whole process to solve the problem, and that's what it's important to me. And I use the videos as a way to document my process, to practice these problems out loud. Just the fact of having a camera in your face puts a little more of something extra. You have to think, you have to make sense to the camera, right? So that's also helps me for the interview process, right? So we're saying that just gonna go ahead and copy this function here and start playing with it. And okay, not miss. I'm gonna go ahead and call these birthday cake candles right here. I'm gonna pass the same array we're using here for the test case. Just gonna pass that over here and help ourselves out. That should return 1 because it's just counting. I'm appending one number to it, right? But what, let's see. Let's add these to a different, let's just add this to a variable and say candles.count. The max items in this candle. Then just return that to see what we get. We get 2. That could be a solution for the Spanish. That could be a solution for that particular input, where we're saying, hey, the talist candles is going to be equal to the count of the max of these candles, and the count, it's saying, hey, there's 2. Let's go ahead and add 6 here. Okay. Let's go ahead and add 5 here. Okay. Let's go ahead and add another 6. Okay. Let's go ahead and have an empty list. Max argument empty. Okay. We know that's not going to happen in our problem because they're specifying that we're always going to have at least one number in the array. But I just wanted to see the behavior of max. Again, I'm trying to learn from that. Okay, so for for that particular test case, we get 2. I'm gonna try to run this code here. I'm gonna just go ahead and I'm not even gonna copy it. I'm gonna try to just and all I'm doing here is saying Talist candles, assigning that to a variable. We don't even need this because I'm basically using a total different approach. And then I'm gonna go ahead and return that here. Talist candles, I'm counting. I don't need that. The max of the candles. That should, at least for that first test case, should be... Ooh, what am I doing? Oh. What is it saying? Oh, I'm returning the length here. I don't need the length anymore. There's no length in Talist candles main. Yeah, for that test case, that should be straightforward. Now, I know this is not the approach in an interview you should use, right? Why? Because I'm heavily relying on 2 methods in Python, right? And yeah, I know for like more advanced coding purposes, when you're focusing on a professional project, you might use these methods because they're heavily improved. Like people have actually worked hard on making this the best implementation possible of these methods. But the whole point in an interview is showing your abilities, right? I'm going to, so again, this is just part of my process. I'm going to submit this code and see all test cases, right? And based on that, I'm going to determine a different approach, what that would be more that will fit better an interview process, right? Where I'm going to learn from that, and that's the whole point. Again, it's 2:00 here. I literally have to start. I have to be work at 3, so I have to start getting ready now. But I'm going to try. I'm going to try that. I'm going just to say, hey, that's one of the approaches I use. So let's go ahead and submit the code. And it's going to pass all test cases. Surprisingly, maybe not. We got one more going. There's always like a crazy, yep. It passed. Hey, you're done. Again, I want to think about this a little deeper, right? I want to actually think about how to solve this problem, counting myself these elements. Yesterday, as part of yesterday problem, this was the way I kind of went through it. This is staircase. No, this is not the problem from. This is the problem from yesterday. Right here. So, minimax sum. Right. I have an array of length. I didn't have to worry about that because the length of the array. And this is yesterday's problem. I'm just kind of reviewing it. Try to get some ideas too because it was something similar. I had a total sum. These are all like edge cases here, just making sure that the min and max value are always initiated to some number. For every number in the array, I add it to the sum, the number. That's the total sum. I get the min and max value. Again here, using the min and max method, which I also have to say these are local, like primary Python methods that come with the language, which in some interview settings are allowed, but I'm trying to stay a little bit away from them. So what would be the other approach? And I just come here and say, hey, for an interview setting, what would be the best way to approach this problem? I learn from it, I make sure I understand it, and then I go back and do it again, right? And so this is probably an n log n. Talking about time complexity, this is probably n log n because I'm counting, and that should go through all the array, through the whole array. It should explore every element in the array, and also I'm finding once the count is done, I'm finding Um, no, backwards. I'm first checking all the max elements, right? And once those elements are done, then I'm counting how many of those max elements I have. So I'm going through the array probably twice. Not really, where because I get the array becomes smaller once I got all the max elements. I just gotta get the max elements and then count these max elements. But end time operation, going through the whole array and counting the max elements, and then I'm counting the elements that are residual from that counting. So I'm counting the max elements, which is another pass, not on the same array, on a fixed array, which is going to be the size of the max elements. It could be the whole list, could be just max elements. In any of these test cases, probably, well, they're hidden. But it could be just a list of 60 elements that are the same. So I have to count over that so that input grows. So I think it would be an n log n time operation. I could be totally wrong. But I'm going to use the help of AI to verify that and learn from it, right? I'm not trying to get a solution for any problem. I'm not trying to not come up with it myself. I'm trying to understand beyond the limits that I know, right? And use of AI for me, it's one of those ways, because yesterday I came here and I've done it for multiple times now. I know it works for me, might not work for the person on the other side. You might have a different method. For me, I come here, study this, learn. I know how it works now, and implement it. Once I understand it, I go back and solve the problem with what I got from the iteration process, right? So basically the premise I'm gonna use is the same that I use for all the... So for the next problem, I have this algorithm. What is the actual time complexity of it, and how could I improve it for an interview setting? Maybe I can fix that, because I'm not trying to improve the time complexity itself, but the algorithm. So let's say for this programming problem, I have the following algorithm. 3. That should do. Gonna paste my code there. Explain the problem. What is the actual time complexity of it, and how could I improve the solution for an interview setting? So I'm very fine that I'm in understanding the time complexity. I think it's an n log n. I could be wrong. So that's what I think it's an n log n for what I explained earlier, right? The count and the max. I'm going through the whole list in time. The whole list, at the size of that list grow, that's going to grow. And on the other side, I'm counting those max elements, which it's another pass through a different list, right? To a different array that it's been holding memory. So it's got to get count now. So just the way I think it is, but maybe not, right? I'm gonna pass the problem here just so this thing understands what I'm trying to solve. I don't like to copy from here, but that should do. That should do for now. So you're in charge of the example. It was 4, 3, 2, and 4. says 4 units high, 2 and 2. Okay. Yeah, there's a good bar. 4 are 4 units high. There are 2 of them, so then return 2. Change to Talus. Just a little context, right? I want to make sure that it understands. There's an operation scanned internally, so n. Okay, so we know that the max operation was n. Candles.count, this operation also scanned entirely once, so it's on. Therefore, the override time complexity is O plus, okay, where n is the number of candles. Okay, so I was wrong because in the sense of thinking they was n log n. And that comes from yesterday having to sort. Where is it? Having to sort right here. I was having to sort this array, and that sort operation was n log n. But in this case, when we talk about overall time complexity, it doesn't matter that it's n plus n. It would be, it's not n squared, right? It's one of them. Space complexity, we know that is big O of 1 because we're using a single variable. We're not creating any extra data structures. ISCONSIDA has a good time complexity. We can make a few improvements, and this is reduce the number of passes through the list to 1, add an input validation, handle edge cases explicitly, possibly improve readability for larger code bases. I could say if the list is empty, return 0, which we don't have to worry about, and that's the thing with these problems that are easy. So far we don't have to worry about edge cases because we know there's always going to be a number based on the constraint. So that's a good point to keep in mind, and that's something that I'm very aware, like as I move forward to more like difficult problems, I know I'm going to have to worry about edge cases. It's good to have it pointed out here first. That way you always keep it in mind. Then max height, you always initialize that to a minus infinity or infinity, depending on the number, if it's positive or negative. Again, that's good practice because you don't want to initialize a value to a 0 or a different type and then get type errors and whatnot. For candle and candles, if the candle is greater than the max height, that's where we are. Okay, max height is equal to candle, count 1, elevate the candles equal max out, count plus 1, and then return the count. Single pass, we only iterate through the list once, finding the max height, counting the talus, time complexity is still in, but only with 1 pass through the list instead of 2. Input validation, explicit initialization. That's another thing, like we don't have to worry about negative candle height because again, we know a slightly longer version might be easier to understand. Flexibility. Edge cases, but for very large lists, you could discuss the possibility of using a max heap data structure, which would allow finding the max and count it in login time. If the data is dynamically changing, in Python specifically, you can mention that for very large lists, the using of collection of counter might be more efficient. Yep, that's things to keep in mind. Again, trying to stay away from those imports while I'm solving programming problems, but also they are allowed in some scenarios and whatnot. Mutability, great. I think this solution here I understand. So I'm basically saying iterate over every candle in the array of candles. If that candle is greater than the max height that we initialize to infinity, or basically a negative number here, we can initialize that to 0. Um, in our case, because we know that we're always gonna have at least one candle of height 1. Okay, so that's something that I think we could do. And then the count, as I started, I thought a count would be a good idea in the first implementation. Then I couldn't. I went completely the other way. But a count to count the frequencies, and then say, hey, if the candle is greater than the max height, then the max height now becomes that height, and the count becomes 1. Now, if the candle is equal to the max height, you add the max height. Okay, this is where we handle duplicate, right? We find the max here, but hey, if the candle it's equal to the if they match, then increase that counter, and that's the only way the count will increase. Because if not, then it would go back to 1. If it finds a number that is greater than itself, it will just go back to 1. But if it's equal to its number, it would increase the count, and then you just return that count. That's pretty cool again, and that's part of the process of learning these things, right? I definitely have to practice more iterative approaches like this, but I don't know why. Like, and this is something personal, but outside of Python, like I've been doing Swift, and I've been also watching too many videos of the Primeagen, and for good or for bad, I enjoy the content, like entertainment purposes, but also he hates Python and all these other languages that are not real languages, right? In his words. But and he said that before, okay? So I'm not putting words on his mouth. But it makes me kind of conscious of using for loops in Python, and I always, when I see an array that it's going to be too big like that, I always try away from that, from a for loop. But then I'm like, it doesn't make sense, because then I'm using methods that go, even though they're optimized, right, they go through the array the same way. So that's a little pointer there I could definitely improve. I have to go now, but I'll definitely get back to this and solve it in an iterative way. I'm gonna implement this myself next time I try to solve this. I understand the premise now, so next time I would just try to go and do it myself without having to look at this code. But now I understand, right? Now I saw a different solution. Now it would be the same for me probably to go here to submissions and check for other, not submissions, that's our mind, discussions. And look for other solutions, right, that people posted. See, this person's used a hash map to count he's got a counter for the greatest. He's going through. Oh, cool. Count candles plus equal 1. Basically the same thing, but he's using a hash map to keep frequency, right? Yeah. Because this is identify the greatest number. If not, this looks like Python. Yeah, this is Python, definitely. He's just using a hash map to do it. But yeah, it's the same if I would go here. But now he's not explaining anything. You just kind of have to know, right, what you're looking at. And that's cool and whatnot, but also I like to have a little more of details. Like, hey, you could do this, you could do that, you can explain this, you can explain that. And that's why I think the help of AI in a lot of cases is very, very handy. I'm hungry now. I gotta try to eat something before I go to work. Thank you for sticking with me till this point. And until the next one, we solve this problem. Hey, we're supposed to get where's the things coming down? Come on. There we go. Now we can go.